what happens when you have multiplication and it's either a binomial times a binomial times a trinomial, or a binomial squared. So in algebra, what happens is that the x goes to both things and the -2 goes to both things. And they've created an acronym to help us remember this. The acronym is that the first ones are multiplied together, the outside ones are multiplied together, the inside ones are multiplied together, and the last ones are multiplied together. First, outside, inside, last. So sometimes you'll hear me say, oh, we just need to FOIL this, because it spells the word FOIL, and it's just a mathematical way for solving this all out. Why does it work? Just a quick little picture of why it works is you can use a rectangle. So if I have a rectangle and I have this length as x plus 4 and this length as x plus 2. The area of the rectangle would be length times width. If you split up your x plus 4 as an x and then 1, 2, 3, 4, and here an x and then 1, 2, it's still the same rectangle, but you can break it up into different sections. There's x plus 2 that way. Maybe I'll draw straight lines, easier to see. Does it make sense that that square with algae tiles would be an x squared? And with algae tiles, this is an x, 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 this is an x. And these are all ones, 1, 1, 1, 1, 1, 1, 1, 1. So I just drew a picture showing the area and looked at my results. According to, if I multiply the first ones together, first times first, I would get x squared. I'm going to put an f over top of that one to represent that that was multiplying my first ones. What happens if I multiply the outside ones? What's x times 4? That would give me plus 4x. Those are my outside ones. If I multiply my inside ones, I get negative 2x. Those are my inside ones. And then my last ones, negative 2 times 4, would be negative 8. Those are my last ones. Notice that we have like terms here. What is 4x minus 2x? Becomes x squared plus 2x minus 8. So I'd like you to try this one. Draw all the arrows, the first ones, the outside ones, the inside ones, and the last ones. And it's just practicing our multiplication in a new form. Okay, check here. You do y times y, you'll get y squared. Outside ones, y times 9, 9y. Negative 6 times y, negative 6y. Negative 6 times 9, negative 54. We have like terms here and here, so we simplify. No like terms with y squared. 9y minus 6y would be plus 3y minus 54. Now, this is a great example of having never seen this before, which is true for all of you right before this class. This question with the two set of brackets would be impossible to do. Okay? Paying attention in class, we learn one technique, and then each of our multiplications are relatively easy. It's not that crazy hard to do, but it would be if we don't pay attention or we don't try it as we're going. Mm-hmm. For us this year, mostly at this level, what makes it hard is you have all the different algebra things put together. You have to remember which one is which. That's what makes it harder. Yes, we are going to learn more. For today, we're just going to look at this one. This is going to be we're going to look at this one. We're going to skip the next one. Well, I'll show you how to do the next one. And then we're going to end at the example at the bottom. Really, everybody did well on the first part where drew your first ones outside, inside, last. M times m, m squared, m times negative 12, negative 12m plus 5m minus 60. Then, these are like terms. If you're at minus 12 and you add 5, where will you end up on your number line? Negative 7. Okay, so just like if they're like terms, meaning that they have the same variable with the same exponent, then you're just adding and subtracting the numbers. And the way that I think about that is here on the number line, I'm starting at negative 12. So there'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're adding 5 to that. So we're starting here. Adding 5 would go in this direction. What number would you end at on your number line? If you were at minus 12 and added 5. Negative 7. And that's how we got the negative 7 right here. Okay, we are going to skip this example. And I'm going to introduce you to the last one, which has 3 things here. So the x doesn't just go to the first 2. It has to go to all 3. And the 4 goes to all 3 as well. Class will end in like 2 minutes. So we're just going to finish up with this one. So if I do all the blue ones first, I'm going to get x cubed minus 3x squared plus 5x. Then I'm going to do all the green arrows next. Plus 4x squared minus 12x plus 20. Do we have any like terms? The x squareds are alike. The x's are alike. The rest don't have like terms. So our final answer for this one, we have an x cubed minus 3 plus 4 plus x squared, plus 5 minus 12, negative 7, plus 20.